Back everyone, I hope you had a good lunch break. During the morning session, we gained valuable perspective and engaged in thought-provoking discussions. The conversations so far have been enriching. I'm confident that the second round will be just as much enriching, if not more. As we take the transition into the next phase of the event, I encourage everyone to remain actively engaged, ask insightful questions, and share their own thoughts and experiences. Remember that the success of these panel discussions hinges on our collective willingness to collaborate, learn from one another, and contribute to the broader discourse. Without further ado, let's dive into the second round of panel discussion. For that, I would like to call Dr. Sue Impe to briefly elaborate the significance of skill building in youth in the context of our theme, and followed by there is a panel discussion. Dr. Sue Impe, kindly come on the stage. Dr. Humaira Bano, if you could come and please be seated here.
So thank you very much for the opportunity to lead a discussion with you, and the emphasis is on discussion. There's no talk prepared, despite the slides. So as part of the initiative for collaboration, there's a fantastic opportunity to work across culture, to work among many people, and not only do we have the materials issues and technical issues, but we also have a lot to do with the human resource. And one of the questions that I'd like to pose is, what do we need moving into the future? Do we need to keep teaching and research the same as we've always done? Will we develop the skills in our engineers that are suitable for them facing the future? Or do we need to modify and build new skills and focus on new activities for the future? One of the things that we've learned from this session, these sessions now, are that collaboration and teamwork, and we can't do this as an individual. We have to work together, and we have to rely on others to do that. So these are already setting out some of the skills that I think need perhaps to focus on. We need to be really inclusive, and we also need to prepare all our materials engineers or a whole range of different activities. So some of the things we can do is, I think we've heard, I'm just going to refer to some notes here, sorry, I hope some notes. Yeah, we heard earlier about the depth of the skill set and a range of different skills that we will need in materials engineers, data mining, those that are good with data, a whole range of different skills. So what I'd like to focus on is perhaps to draw out some of the skills that you think are important, and then ask ourselves, across the board, are we teaching all of our students the same? Are we teaching our female students the same? Should we be differentiating? Should we be taking account of this? And how do we prepare our workforce for the future? An anecdote I have is that some of my other educators in other universities have said that actually to put this all on the students is completely unfair. Some of them are really anxious about the future, and so we need to be building confidence in these youngsters. It's not in you. It's not down to you as individuals, but down to the whole of our community to make this happen and to prepare everyone for the future. So what I'd like to do with my colleague is to perhaps draw out some of those skills so that we can prioritise them as teachers and educators for the future. Humera, did you want to say anything in particular? Pardon? No, that's all I have. Do you want to? Okay. I have not had a vast industrial experience. I do have a slide on this actually. Let me just. Okay, so just a brief bit about me. I did my undergraduate, so I have studied all the time in the UK. I've never been out of the UK for study, so my experience is very small. I did chemistry for my first degree, and then I worked as a pharmaceutical chemist making drugs for a company. And I thought at that time, there must be more to this life than making drugs or synthetic chemistry. Apologies to those synthetic chemists. And I was really interested in the application of materials or of products and chemistry. So I had a look around universities and did a master's in materials, aerospace materials, focusing on metallurgy. And then I did a PhD on a sustainable approach to recycling aluminium beverage cans, so Coke cans. A long while ago, that was still an issue and still is. So recycling aluminium I did with a company in the UK who was setting up a recycling plant in Canada. The recycling plant didn't go ahead, but I carried on with my PhD, and then I stayed at Cranfield doing a whole variety of things, mainly surface engineering, and became a member of academic staff as a postdoc, and now lecture on a whole range of different activities. But the interesting thing is, years later, I've come back to aerospace materials. I used to look after a number of courses on nanotechnology, on advanced materials, but now I'm back to aerospace. There is some circularity here on aerospace materials. And this is not just about, the whole of aerospace is to make it, so we need people to be transported, we need flights, we need goods transported, we can't just stop aviation, and so we need to do that in a sustainable way. So sustainable aviation, and there's a whole range of different activities looking at the fuels, or how we're going to what we use for propulsion in a good way, efficient way. So the whole range of things there, and it's quite a disruptive time for aerospace. So quite interesting from a research point of view. I'm going to share this next slide with my colleague because I think she works in a very similar way on corrosion. But the sorts of things I do now, this is what I was doing this year. We're working on materials for batteries. This is part of sustainable aerospace, but also looking at how we look at corrosion, selection of our materials, our pipe work, a range of activities there, heat pumps, trying to reduce corrosion there. Humera, did you want to say a little bit about your journey, which may be very different?
It's okay.
Okay.
Continue, please.
So I'm going to skip.
Okay. It's okay. I'll talk later.
Okay. So, what skills do we need for a good materials engineer? To start the discussion, this is not a fully comprehensive list. Strong communication skills. But this is for not only for materials engineers, but a whole range. But this is my opinion, and I'm just one in a group of you. Organisational skills. We need to meet deadlines and resource and plan accordingly. Take on responsibility. These ladies here doing, it doesn't matter what you're doing, but to take responsibility to lead others. And I like what was being said about the NUST students, that when you say you're going to do something, it's done. This is all part of being a good professional in whatever you approach. IT skills. I came over here with a laptop with no software on it. With, you know, good IT skills here. So engineering work. What other things do we think? So the questions I want to pose are, one, what other skills, transferable skills, should we be developing? And do you think are really important? And what do you want to learn? What do you think you need to learn for the future? For those younger ones in the audience. And the next thing I want to talk about separately are females different, or are they exactly the same thing? Okay. So I'm going to just move away from here, so I stop talking, and ask if there are any comments you want to make on what's been said so far. What skills for a good materials engineer, or any engineer? Scientist, chemist, data analysis.
Can I add one thing? So,
Yes, please.
so how many among you are doing currently the undergraduate in materials here? Can you raise your hand? Most are the more mature students, right? So most of you are academics, masters or PhD? All right, so but you already have a journey for bachelor's, no? So what I can add here is about one of the theme of this partnership grant, that do you think, because climate change is a big problem, right? And there are emerging technologies for energy, sustainable energy, sustainability of the energy, right? And products which really take us towards net zero, less carbon emission, less carbon footprint, do actually save water. That's the buzzwords which we normally hear. Now most of you have done your undergraduate, right? One of the themes which we actually try to run in our partnership program, do you really think that while you are doing your undergraduate, and it's not limited to materials, even for mechanical engineers, I'm from mechanical engineering background, now I'm thinking that if I'd be at the time when I just do a little bit reverse to my life, at the time of centuries ago, when I was doing my bachelor's, I supposed to be say, let's suppose, to design a gear or bearing, I must have an idea about how to make that gear sustainable, or how it will be used in a circular fashion, right? It will not be dumbed down somewhere to increase the carbon footprint, or to actually put an impact on carbon emission, or so and so forth. So what you think, when you have done your undergraduate, perhaps recently or a few years back, how much you think it's necessary, by keeping in mind the issues which we are discussing under the context of this workshop, we should include these topics as a part of a teaching content, right? I do understand we have 40 or 42 modules for undergraduate. I do understand there are lots of practical classes, right? But because these things, if you weren't able to live on this planet, there's no benefit would become engineer, isn't it? So what is your ideas? What do you think? How it's supposed to be incorporated in our ongoing bachelor's program or master's program? Even, as I mentioned, even you are doing bachelor's in mechanical or environmental or materials, everybody's supposed to play its part in that capacity, right? So if even you just see the panelists or the people who are belong, somebody is from chemistry, somebody is from engineering, somebody is actually from environmental, and everybody is actually talking about carbon emission, climate change. So this is one of the things which we have put in the proposal, and we want the young people who are currently working as a student or who have just passed dear undergraduate, what you think, how these topics supposed to incorporate in the current bachelor's degree content, teaching content, or just you say, oh, there's no need to be add in the modules, just give us short courses or workshop or something like this. I gave an example in ComSet that 15, 16 years ago I used to see a talk show and there was a debate going on that perhaps you have heard about that debate. Do we have to teach humanities modules to engineering students? So one of the professors was saying, you must make it incumbent, because to be a good engineer, you first to be a good human, right? Similarly now, if you want to make this planet livable, what you people think, how we actually incorporate in terms of education? Should be a part of our normal degree program, or should we actually incorporate like these kind of workshops? Now the floor is yours. We need your opinion. Otherwise, I will force you to talk. Okay.
Dr. Khan, before discussion, I would like to add a point at this stage. I believe that women are closely connected to the surrounding, and women and child education can strengthen climate strategies in a way if we train our students and the faculty, teachers, women and the children at different stages, so that they would be able to take pro-environmental decisions in the future. For example, for me, if we develop some kind of courses which could help them to develop the green skills, and then we think that the green jobs in future. So this could be a strategy by adopting which we can save our environment or the climate changes that are going on or happening in these days. So it is very important. So we would like to listen from your side. What is your opinion? What kind of courses are required in order to train the women and the men from, we can say, all genders, including our children, to handle the different challenges we are facing in terms of environment and climate change. So thank you. So now the house is open for discussion.
Sir, I would comment on the climate change which have been asked by our professor. I think they mentioned we must include the courses in bachelor's, but I think we should include in intermediate level first, because in the matriculation as well as intermediate level, there are the students who can learn the basics of climate change as well. So in the natural sciences books of the intermediate and matriculation of even in the A levels as well, it's not I learned it, there is not even a single debate on even a single chapter on climate change as well. This is the issue of the almost half a century. So we first include in intermediate level, and then we have to मतलब हमें कुछ credit hours कर देने चाहिए कि some credit hours should be compulsory in the climate change course, or even the hot topics of green energy as well, but this kind of thing. But you know, the HEC's new policy is coming now, 2023. There is no documentation regards it, but our government is responsible. We can't do anything, I think.
Thank you.
Can I thank you for your comments? Can I just clarify? Do you think, are you suggesting that some of the awareness should be in every part of education?
Yes.
Yes.
Do you think it's not at the moment? Do you think the children are not aware of some of the issues?
Yes, in Pakistan, absolutely. I haven't seen any in A levels as well, intermediate, even in the bachelor's. There is no debate or even on the single chapter on climate change.
Don't you think we should start the awareness with some practical? For example, we can create awareness in the children with a point that keep the environment clean,
Yes,
and keep the environment green. In these days, different school systems, they conduct activities related to how to save environment, and since my kids are studying at different grades in the school, so I usually observe that they make projects and presentations related to how to save the environment and plant trees, etc. So I think although we do not have particular courses at school level, but in the form of different science projects, different school systems are contributing to create awareness among our children, and we are expecting that these kids, when they are grown up, they will have a better understanding of the idea and about the climate changes as well. So that we are getting right now at this stage. I think if we go 10, 12 years back, so at that stage the discussion related to the environment, how to save the environment, and the discussion related to the climate change was not in consideration. So I think there a step and initiation has been started regarding the awareness, but it is not in the form of course. So very nice suggestion, I appreciate, thank you. So there should be a chapter at least in the books, in the textbooks, so that at this even at that stage kids can get knowledge about the environment, about the climate changes, etc. Thank you.
I had an opportunity to see some in the Tech Park, the Innovation Centre yesterday, and there was a company there that were working on technology transfer for 8 to 12-year-olds.
Yes, yes, to the kids.
And I asked them what were the most important things they thought, and they said introducing technology as an opportunity to introducing technology early too in the context of climate change, so that people feel, the youngsters feel as though there are tools to help them do that.
Yes.
May I comment on as Dr. Humaira mentioned about the women and the children education. Actually, as the youngsters also mentioned here, it's not only the university level. Even we remember at our childhood, we used to outreach. We are going into the parks or collecting some leaves, even collecting some flowers, putting into the book. So when you outreach, then you are more aware of the climate change.
Yes.
So how to look into your society, what are the needs of the society, and when this is sustainable development goals is all about to outreach to the society. So these should be the built-in from the school level, from the primary level, because we used to say I used to say when they come to the university, most of the things they have already learned, or the damage which has happened is happened.
Yeah.
So it cannot be recovered in 4 years of undergrad education. So I think it's the school level where the role of the, like I work in the water, so I say the most stakeholder at the home is the female in our society.
Yes.
Because from the kitchen to the washing of the clothes and all the cleaning, so the main stakeholder is the female, the woman. So if she is not aware of that, then I think the others cannot take that. Thank you very much.
Yes, yes, Dr. Adnan, please.
Since we are talking about climate change, I can see the engagement from the students, which is great. I think everybody's good to see. There are more students here, more than staff, that's for sure. Climate change, we talk about power generation, we talk about renewable energy. What we don't talk much about is how to consume the electricity and how to, and about the waste management. As just Dr. Abid mentioned, it starts from household, for example, right? So can one imagine how many type of bins I have in my house in the UK? What different type, altogether with different colors, council has given us for different kind of waste?
3, I expect 3, maybe?
There are 4 types or 4 different
Okay.
colors, right? And of course, at that level, at household level, we know, the child know from the beginning that the plastic waste goes in that one, the general waste go in the other bin, the plant waste goes into the other one. So all different type of waste goes into different bins, and then we recycle it. Of course, the council does in the right form. And of course, it does affect climate change then, doesn't it? Yeah? Imagine the waste going in just one bin, which has got plastic and metals and general waste. So yes, it's out from the household, and if we give this education, the mothers can, the fathers can, not just mother, both parents are supposed to give this education. The primary school system, of course, make you aware of this very important subject, which has become really a focus for the academia and research and the government, right? You're talking about UK COP28 now, a target for 2050, net zero. All these, this has really become a big thing. Everybody knows 1.5 degree increase in temperature. What will it do to the whole globe? And that's why we have set the targets. Europe has taken really strict measures to cut down coal combustion and focus on renewables. So I think that's all I wanted to make a comment. Anybody else? We are
Thank
not
you,
drifting
Dr.
from the subject, are we? Or
Thank you, Dr. Adnan. Thank you.
okay.
So it means that knowledge about the things is important, but the implementation of knowledge is also a very important point, as Dr. Abid and Dr. Adnan pointed the fact. So I would like to hear some points from this side, if you can share your opinion or thoughts related to the topic. Anything you want to share?
It's not I'm not commenting, rather I'm asking a question. Lately, everybody is hearing about AI, artificial intelligence, and it is making, especially when it comes to education, a difference in many ways. If you give the assignment to the students, they are using AI for their different purposes. I'm asking all the participants, especially the teachers, how are they coping with this AI material? How you differentiate between cheating, plagiarism, and the use of artificial AI, chat, GPT, etc., etc. Anybody commenting on this thing and how it could be related to the skills or something like that?
Sue, would you like to say?
I don't know if I have the answer. I'm checking with my colleagues here. But I think at the moment we have no policy. Our advice is for the students not to use, but it is part of the mix of information. So our policy would be to advise not to use that, but actually to embrace it if it's happening, not to penalise necessarily, but it's part of the rich tapestry of information, and as students you've got to navigate through that. But that's one. Am I, Mohammed?
We have a recent meeting, especially in the context of ChatGPT, and in Cranfield the mood of teaching is quite reflective based mood of teaching. We don't really go on the board and start writing equations. We have very reflective based teaching mood, and at the end of the assessment is also been done on open assignments. Almost 90+% of our modules assist based on open assignments. Now, it opens up very big debate that when you have the software like ChatGPT and you are giving an assessment based on assignment, how you maintain that to be a fair, right? They don't use this and they will actually change. So the recent course director forum meeting which we had in Cranfield, we found it that we can't really avoid the student should not use it. We don't really have any system or any surveillance for that. However, up till whatever we have heard and the advancements in ChatGPT, if you are giving an open book assignment or an assignment where you want actually to student put in whatever the questions we have asked him, we said the signal is green that we should not worry about, because if you are crafting your questions which are more concept where you are actually asking them to provide some new thoughts or some kind of new conceptual proofs or their own ideas to solve a problem. So we normally give them research-based problems. Whatever we have in the lab, the same kind of problems we ask them to put in the assignment, right? So, and we believe there's no straightforward solution for those problems. So when there's no straightforward solution, it means that there might be multiple routes to solve that problem. And at this moment, up till the current knowledge, I'm not sure what will happen after the next 5 years. Maybe they will make ChatGPT more adaptable, and it provides solutions which are novel solution for those problems which have not been explored. Because at this moment we have this understanding that it gets the content from the web, whatever is available, and then it applies the intelligence, isn't it? So if there's nothing available on that topic, what will end up it? So that saves our concern about that it will be copied and it will be pasted directly from an online tool. So this is the recent discussion we had for the next year assessment. And then we have also discussed that, okay, we'll try to review this policy for next year. It depends upon how technology will advance. So at this moment, we are not very much concerned about that.
Well, it's not that we're not concerned, but we have to manage the change and adapt. And I think that's one of the things here is somehow we have to be adaptable. And do you teach adaptability, or do you how do you respond appropriately to changes?
Adaptability in teaching methods.
Hmm?
In teaching methods. I'm talking about adaptability in teaching methods.
So perhaps I could pose a question. If I was normally asking my new student cohort what they want, why they are at the university, they may say because we want a technical. We want to know more about your subject area, but I suspect not. They usually say because we want a good job. We want a job. Is that the case for you? Are you studying for a job, or are you studying because you think will I face a body of students that say because we want the planet to continue? It's a different driver. How do I prepare for when they say, well, perhaps I won't get the students in the first place, but we all need money to survive. We all need to have that finance, and that's got to be linked. So is there anything that anybody else wants to say about what skills do you feel ready to face the future? Is it all technical delivery, or do you think there are skills that you want to develop when you were studying, or that you haven't been taught? Or
As you asked about the teaching skills, I believe there should be that critical thinking among the teachers. Many of the teachers in Pakistan, especially in the universities, they are able to write multiple research papers, but when we see their slides, there's the copy pasting from the books. I think if they write a book of research papers, why they are reluctant to write their own slides, or there are exceptions, but I'm respecting all teachers. But there is even I was studying in the college, they have the ability to show us slides, animations, but in the universities, in the basics as well, in the first 2 years of bachelor's, when the basics courses are studying, there is no critical thinking. I am belonging to chemistry department. I am telling to you that our teachers just copying from the textbooks which are recommended by them in their slides, and then teach from them. Why they can't do any animations, why they can't write in their own wordings, and why if they write multiple research papers, heavy research papers, research items, they I think they focus more on research to excel in citations, so that they got promotions. Exceptions are there, but they are not interested in as much as in teaching as they are in research. So I think there should be the balance between teaching and research in the universities, and particularly there should be, every good researcher is not a good teacher, so there should be the test between the communication skills in the teaching. In Pakistan, unfortunately, the college level, there is the very high level testing before appointing in the college lecturer. The Public Survey Commission is an institution, but in universities there is the other requirements. There are not as much. I am belong to chemistry department, SNS, third semester in BS.
It seems you are not satisfied. Okay, so what can I say? I'm also a teacher and teaching at the Department of Chemistry, University of Karachi. So on a lighter note, I would like to say, I would like to have a discussion with you separately. We'll try to teach a topic and then evaluate. So in our system, we have a great respect for our teachers. So at this stage, if you expect that each and every point would be something like you explained you in a way that you can get very easily. So different teachers have different opinion. This I'm talking as a student when I was a student and different teachers were teaching. So some teachers, when they teach, they talk at the level of the students. And some teachers, when they deliver lecture, so they have their standard, they have their level, and their approach is to develop a thinking in yourself or ability in yourself to come to over there and catch their standard and try to get something what they want to deliver. So now, after having an experience of more than 18 years in this field, I believe and I will evaluate that every teacher has a different contribution or had a different contribution in my career. So we learn from our teacher. If you say it is all about the subject that you want to learn, so it is not important. Many teachers give you a different kind of skills. Some increase your thinking ability. Some just talk about the contents that you want to listen. So teaching is in fact a different talent, I believe, as a teacher. Not everybody has this talent. But you cannot say that in these days. I think you're a little bit annoying with the kind of standards that we have. This is a requirement as well from the Higher Education Commission to create a balance between the teaching and research as well. So mostly as far as my university is concerned, University of Karachi, so we have a number of students in the bachelor's program and in the master's program, and then in MPhil PhD program as well. So we have our main responsibility is basically to teach. So we are very much engaged in teaching at these levels in the morning program and in the evening program. And then as a researcher, we try to find some time in between different slots, and we try to work on the ideas that we have in our mind. So this just I would like to share with you that this is not the only picture that the teachers here at university levels are very much engaged in teaching, in research, and they are not teaching well. So maybe you have a different satisfactory level, so you are not satisfied, but I believe maybe this is not the opinion of other students as well. So if anybody want to share,
I'd just like to say myself that actually I think critical thinking is really, really important. However, I don't know if you're taught about Bloom's taxonomy, where we have to build the building blocks of understanding, fundamentals. We have to build these building blocks, and actually critical thinking, evaluating, analysis is a higher level of understanding. So I think there's room for both, where you have to set Now, my university says at postgraduate level, it should only be higher levels of evaluation and higher levels of analysis. But I don't think that's possible to do unless you've got the fundamentals in place, because you don't have the information to argue with and to provide yourself with a sensible argument, to put the information together and to understand how to create new information and an argument, because you have to have that fundamental understanding. So I think there's room for both, but I actually agree. I don't agree necessarily that the teachers have to be shared, but I think critical thinking is a really important skill. So thank you for bringing that out.
Sorry, I just want to add a point that most of the students, they are in universities to learn something, but at actual, they don't know the purpose of the university. Actually, universities are built to produce knowledge, and they teach, but they produce knowledge through that teaching. So maybe in some cases, some students, they actually they fail to follow the vision of their supervisor. So sometimes there is a gap, and you have to understand that why you are in a university. You are the part of that knowledge production process. Teaching is something else, and knowledge production is something else. So teacher, most of the time, when he focused on knowledge production, students miss to learn what he is actually doing. And the other thing, again, teaching is an art, and not, you know, some people are very outspoken. So, and some people, they are not good in terms of elaborating what they have in their mind. So that is the point, actually.
Thank you very much, sir, for adding such a good point and the vision of universities. Thank you.
Yeah.
Yes, please.
I have a question. As you said, a good material engineer, I believe a good material engineer is the one who have both theoretical and practical background, strong practical background actually. So we can get the theoretical background from the universities or from the books, but as far as our academia is concerned, I believe we need a strong academia and industrial relationship.
Nice.
To develop a more practical approach or to engage projects from the industry towards academia, so our graduates get practical skills actually, a real problematic skills from renewable sources or whatever the problem is the industry is facing at the moment. So in Pakistan, I believe we don't have a strong industrial academia relationship, so we need to focus on that. So our graduates should be more practical than theoretical.
Can you say a little bit more about being practical? What sort of things might you
Because
have you got in
when
your mind?
our engineers went into industry, they are not much have the knowledge to deal with that equipments or to deal with the environment of the industry, because it's quite different. Our university students are quite pampered, we can say, but the environment of the industry is very much different. So students should be aware of the environment of the industry while they are studying their postgraduate or graduate programs. So for that, universities need to build relationship with the industry, and their students work on their product for new products or research on their products by using their labs or their materials, or test them on their industry in their universities by using their facilities. So by that way we can, I think, approach the real things.
Thank you.
It's a very useful comment. I mean, I was thinking as you were talking about practical skills for industry, but I ask myself, who is the final customer here? Is it industry? Or are we, in your case, but if I'm thinking about climate change, there may be a very big difference between what you're asked to do for your industrial employer and what you think is the right thing to do for, it brings up a whole load of moral codes, doesn't it? If you don't think your employer, or if you were employed, is doing the right thing for the planet, or is necessarily building the financial resource because it can be done, this brings up a whole different avenue. So who is your employer in the case of a climate change push and an agenda? Is quite different to know who that stakeholder now is. But I agree with you about the practical skills, but that's, to me, that's part of learning, a rounded learning, and I'm very, I mean, if you don't have that in your learning, it's amazing that you can get to such a high academic level without the practical skills to embed the knowledge. So it's a compliment to you guys that you managed to do that without lots of practical skills, but I agree, I think it's essential.
Exactly, because our graduates ultimately go to the industry finally. So they have to serve the community, serve the industry. So it's better if they have the knowledge before getting into that environment.
I would like to make a comment here. So, may I say something before you say? So, about Usman, Ahmad Usman, he's a great example of securing a PhD program in our university. How he did it, I can tell you, but he can tell himself. But I think it's a learning for a lot of you who wants to do a PhD in Cranfield or somewhere else, how he got his place in our department with me in some industries. Would you like to say it, or shall I? Yeah? Okay. So if you take a few minutes and just, so I think it will be a learning for others. So take 5 minutes and then you can.
Okay, thank you so much. Actually, I'm a graduate from National Textile University in 2018. And after that, I went into the industry as every graduate want to in the industry. But at the part-time, I started my master degree in material sciences and did my master degree in 2020. And in the meantime, I have almost 2 to 3 years of industrial experience. So I served the National Textile University as a lab engineer for a year, and I got appointment from ExxonMobil in Saudi Arabia in the same year at the end of 2020 and served there for almost 2 years. And I have a passion for PhD, a doctor with my name. So I was looking to different projects related to my courses. So I served, when I was as a lab engineer in National Textile University, I served polymer synthesis lab and unit operation lab. So I have a keen interest in heat exchangers and turbine systems like materials. And luckily, Dr. Adan Interview has project in that domain. So I applied for that, and after successful interviews, I got the funding. And
He's not telling the right story. On holiday, he sent me an email, I read it over there, and while I was on holiday on vacation, I said, okay, can you have a chat? So we had a team meeting for half an hour, 40 minutes. And he just simply talked about his passion on power generation sector, his passion on coatings and corrosion. I said, okay, so he really impressed me with his knowledge. He used to make it in Saudi Arabia. When I went back to the UK at the university, I spoke to their learning advisors, like Mario Student, and I asked Mario, the director of that company, I've got a candidate who's quite very much passionate about PhD, and would you like to have an interview with him? So they organized a session with Usman, and Mario was so impressed. He said, you know, we have to offer him a place. Yeah. So they offered him full funded PhD. Now he's coming to UK next month, right? So this is just to show you, if there's a will, there's a way. So approach us. We are many of us there. At
So
Cranfield,
what skills do we learn there? Good communicator.
communication. Don't
I
be
mean, a
don't-
lot of
yeah.
luck.
Not
A lot
be
of luck.
afraid.
Not saying anything
Be
against you,
there at the
but
right time. That's the phrase
the
we
right
use.
time and opportunity.
Absolutely. So I think that's something I want to share. Thanks, Usman.
Just to add here, in Cranfield University, and perhaps on all the university, but in Cranfield we have a research opportunities page. If you go there, you'll find lots of topics which are advertised or published by each individual academic, and the research opportunities which they actually have in their labs at this moment. You find something which Sue has advertised, or myself, or Adnan, or other colleagues as well. And if you normally, when the students are interested in that, then they know, okay, this person is actually offering it. There is a contact email address there. You can start, like in this overall example, one of the skills which we are mentioning is about communication. Start talking to them, start asking them, and then the opportunities will open up ahead. Definitely, you must be very lucky, but if you start speaking with the people, opportunities normally come in with the time, and then hopefully, so you'll find, if you'll visit the research opportunity, as soon as you go on cranfield.ac.uk, you'll find research opportunities page. Click on that and you'll find lots of available PhD opportunities at this moment.
But I think also it's about speaking to the right person, and so not everything is always on the internet. It's been speaking to the right people. Any other? Did you want to say something?
I think I lost what I was trying to say. Can you hear me? Yeah. So it's a really good discussion. I was just trying to keep my mind on the track while we were moving from one topic to the other. But I really, every sort of a comment that is made is very interesting. So I will just pick up the start of the discussion that in terms of the skill set, what should we striving for a skill set. I think the question that Sue was posing for a material engineers, but whether it's a material engineer or I quite often have the discussion with my engineering colleagues there, and the one thing I always pose them that then when I say to them something related to literature, they look at my face. If I say something about, ask them, have you ever read Banu Qudsiya, or have you ever read someone else, they look at and say, who are these people? So what it relates to, it goes back to those skill sets that an engineer should have. And one of that key skill set that I learned when I was at UCL, I don't know whether they still have this on their front page on the Civil, Environmental and Geometric Engineering page, building a better society with a contextual understanding. An engineer can always come up with a solution, a sustainable solution, if he have or if they have contextual understanding. What it means that we were looking at, this afternoon, walking in a corridor, quite a lot of material damage just underneath these panels for ACs. So there is a solution. Someone will come up with a solution. But that solution, when this material was developed, have we thought that the material is being put in an area that might have a high moisture content? And this is what it means, that an engineer is there to come up with a solution. And believe me that a researcher, a PhD engineer, is completely capable of transforming this world, because they know the fundamentals, how to devise a solution. But if they have this added element of contextual understanding, that where this solution will be used, what are the surroundings, and that goes beyond the technicalities. It also have the social domain in it, in what society, that will have the huge impact. And when it comes to the skill set, and I always believe that everyone, and engineers definitely, and I appreciate the comments coming from here, the university should be a place where everyone can say whatever they think, and there shouldn't be any bar on anybody. But one thing is that within the universities, I firmly believe that the universities are there to create, curate, and then transform the knowledge. So we create the knowledge, then we curate it. Historically, we were always curating it, putting it into shelves. But now, we are transforming it, and that is the key for a knowledge-based economy, not for a country like Pakistan, but all over the world. And engineers and all the other skill sets, but primarily engineers, because we are in here in this sort of engineering department, can play a key role in building these knowledge-based economies, and universities are providing them a platform. I appreciate the comment made here that engineers, and I'm very proud of being Pakistani, and I can tell you that when I walk in these corridors, the facilities that I can see in here, they're 100 times better than we had our masters. And I could see the impact of that. And the key thing is that whatever you do, always get ready to disregard the received wisdom. What it means that everybody can tell you this cannot be done or this can be done in this way. Try what you believe in. And once you try that what you believe in terms of the solution, there are loads of platforms available in our universities where you can test those solutions. So this is where I thought that in terms of the skill set, we should think about the critical thinking, disregard of the received wisdom, along with always thinking out of the box. Because the one problem with academic training, what we get is, we are being always trained in a disciplined way, think always in a confined way, in an ordered, while quite often discovery lies in when we disregard the order. So I'm not saying not to follow any discipline. What I'm saying that thinking out of the box, and that's a key skill set that always I think will lead you to a solution that is more sustainable, that is innovative.
Thank you. I think that also transcends, I think that also transcends sort of across disciplines. If you're working with somebody in another discipline, you can learn an awful lot just because of the way we do things in different disciplines. So there's a lot of learning there.
Okay, thank you. I'm Dr. Taha Interview, Chairman for Civil Engineering for all campuses in ComSat University. I want to make comments on a couple of things. First thing is a student mentioned about the methodology of teaching, and I agree. Nowadays, the teachers and faculty should teach the students in a way the sessions should be interactive, the knowledge should be recent and updated. Because now the time is very different, because you have to give lecture in a manner so that it attracts you, attracts the students, and they can understand and they can feel entertainment in it. For example, I'm a professor in disasters and geographic and information system, remote sensing. So what I normally do, for example, I taught earthquake. So I did not teach earthquake what happened in 1930. The recent earthquake was in Turkey, so I discussed and made my slides, videos on the basis of that earthquake. Similarly, on floods. Now, floods in Pakistan was, in 2020 was very common, and then the last 10 years and even in 22. So I discuss about that. And also, it's very important to show the videos, and also another important aspect is the software skills that should be imparted to the students. So these are important things, so that students and from the students' point of view, they should also, participate in the discussion. What happens in my class, I do interactive sessions, and for example, as a teacher, I say I'm expecting, okay, that I will discuss, but I will also expect my students to participate. So if you, sometimes come to ComSat Adaptability, and you will see the students are also very, they will interact with you. This is first thing for the teachers. And second thing, in NUST is mashallah, is one of the top universities. And important thing is, your communication skills. Now this panel from UK is here, different universities, professors from different universities are here. So you need to participate, need to discuss the things. whatever the things comes to your mind. Maybe you have a research interest which has common interest the professor from these university. So you need to bring that interest, and also, you know, to be successful in your life. It doesn't matter that from where you complete your degrees. Important is things how you can present yourself. Sometimes some people can do little, but when they present in an effective manner, so they can, you know, they can reach to the top in a very short time. But a lot of people have a lot of knowledge, but they can't show, they can't present, they cannot show, so then they can progress, but with a very slow pace. So very important in the teaching style, we should have effective communication, presentation skill. In my all courses, I teach that. Thank you very much.
So thank you very much. So just for the last 5 minutes, and I'd hope to wrap this up a little earlier, for the ladies in the audience, are there any particular things we have not discussed which you think are relevant or important to raise as, because we have not been, we have or we haven't been talking about female engineers or female scientists? Is there anything about what we've been talking about that does not relate to general engineers that are faced by women? We should have given more voice to this, but I'll lead with saying, when we talk about presenting and confidence, I think there is some work that says that, some research that says that ladies will tend to hang back, and in fact I probably will have exhibited just that. I should have stopped this a lot earlier. I didn't like to interrupt my male colleagues, but I should have stopped this earlier to say, actually, everybody has a voice, and perhaps the ladies need more space to be very vocal. Certainly in the UK, given men and women, we tend, I think the data says that ladies will tend to have less confidence, less perception of their own ability than men do. Given the same qualifications, the same achievements and skill sets, a lady will tend to always say, I think I can, rather than I absolutely can. So I don't know if it's the same in Pakistan, perhaps not, but certainly in the UK, we are advised to give ladies space to say, or to have not this bias, that to give them confidence. And as children, we should be giving our girls confidence to say that you are equal or better than. In fact, I think the data in Pakistan shows that the ladies are academically more gifted. So you need the confidence to be able to tell people that. Is there anything from the audience here? Interesting. No.
Just to make life easy and very joyous, who would like to volunteer?
Just to say that the organisers have all been female, everything's been organised by the females. Well done, ladies.
I just want to add one thing. I belong from Gilgit-Baltistan. That is one of the most vulnerable places with respect to climate change. And we have one campaign running in our area that is called No Plastic, Plastic Free Hunza. So it's basically, we don't use plastic bags. We make cloth bags at our homes. And most of the people who are making these clothes, these are women. I mean, the girls, we make these bags at home, and we use these bags whenever we go for shopping. And I guess it's one of the, it's a good thing to do. And we are also doing it here at NUST. We are not using plastic bags, but instead we are using these paper bags. So I guess it's a very good practice to do.
It's a good comment, yeah. I was pleased to see that at our university, only last month, they stopped using disposable cups in the coffee machines. I don't know if that's because we've run out, but the thought of really using disposable cups for all the students was just nuts, really. We should be having our own cups or at least washing them up. But thank you for your comment. Anything else? You have a voice, ladies. You have a voice, use it. I'm just going to say, sorry, interrupting. I'm just going to share something. When I was younger, I went to the Netherlands with some male colleagues. And I really enjoyed my time. I was looking at a transmission electron microscope. I loved the sessions. I loved the teaching. There was some lady with me doing the teaching. Later in the UK, I met her again. And we happened to be wearing the same clothes. And I said something to her about that because I felt comfortable approaching her. She had no recollection of me whatsoever. She did not remember I was in the Netherlands. She didn't remember I was with her. And I took that to mean you actually need to speak up more. Do not be present in the room and not say anything. You don't always have to say something for the sake of it, but do not allow yourself to have my experience of being somewhere which I loved being and nobody even knew I was there. That wasn't a good point. Okay. So I just share that with you. It may not be the same in Pakistan, but you
very
have a
encouraging
voice.
comment. So I just want to know how we can use industry-academia linkage in order to develop awareness in all genders about climate change. So if anybody would like to comment on this. Can we use industry-academia linkage, or right now we don't have, in order to bring awareness among all genders, in women, in children, in males, about the climate changes? Do you think, for example, she mentioned that avoid plastics, so there's a lot of waste from the industry, and this waste come out of the industry, usually go in the water, in the sea as well. So again, pollution, which is related to the climate change, marine pollution is also related to. So do you think that we can use industry-academia linkage for the development of some courses, in the form of some courses at any level? Is any suggestion that you would like to have shared with us? Yes, sir, please, I would like to hear from you. Yes.
Interested in, even they are not ready to listen about the climate change, because they will suffer if we force them to adopt good practices that are not disturbing this climate.
So is legislation important? Is there?
Yeah, they are very much against the legislation as well, industry. So this is just one aspect. I think it's not about the industry-academia linkages. I think we should more focus on making new rules.
So in the UK, I think there are incentives, and so we are given. I have had, not lots now, but one or two companies that want to be seen to be working in sustainable approaches, but it should be more than wanting to be seen. So maybe they will put their money there if they think there is economies to be made.
Good afternoon.
Hi Phil, how are you?
Good afternoon, sir. Hello, sir. Can you hear us? Okay. It's mic. Sorry. Good afternoon, sir.
Right. Thanks for making the link. Great to hear from you.
Okay. Sir, we're just concluding the previous session. We'll just be with you in a minute or so.
Yeah, that's fine. No problem. Can you hear me okay?
Yeah, you're very clear, Phil. Thank you. It's Sue here. I've overrun this session, and we've just got a couple more questions to take. So we're talking about industry academia linkage and who will pay for climate change. So
right. Oh,
yeah.
Brilliant.
So you might have, some comments to make there. But there was a couple more questions if you can bear with us.
No problem at all. I'm fine for time. That's great. Just shout when you're ready.
Yeah, I want to say
Thank you,
something
sir.
about industry and academia linkage.
You would like to continue or? Okay, thank you. Thank you. Yes, please.
Yeah. It is an actual link between when our industries are linked with the academia. Industry make, like for example, if I give example, we make plastic and the plastic bottles, but industrial people just produce. Then everything has its end of life. And it has like its impact on the environment. Even if I talk about the biodegradable plastics, we say that it's biodegradable. Actually, sometimes it's not biodegradable, and then when it disappears in the atmosphere, it then again converted into the microplastics. Microplastics, again, there is another science. Industries just things produce, but the academia have the solution for, like, if we talk about the sustainability, increase in the temperature, industries produce, but they don't think that what's like its after effects, what's its end of life. Then academia give them solutions, then propose different solutions, and then we use the green, if I talk about the polymers, there are the different PVC, PMMA, acrylates, but instead of this, we use the bio-based things that have different impacts on the environment, and without academia, industries, I think, not exist, and then our purpose is sustainability and the temperature control. Without academia, it's impossible. But it's only possible when there is a strong linkages between the academia and the industry. In Pakistan, it's not good, but in overall in the world, it's good. And another suggestion I want to say that in all over the world, as well as in Pakistan, there should be a thought process. We are in the race that we are producing, we are attaining some objective of the research, but what is its end? What is its effect on the environment? Our students should be aware of this, that what's its effect? Then when we will produce these products, after that, what will be the effect on the temperature? What's its end of life? What is its effect on our oceans? Then again, it's a food chain. We are part of this planet, and then everything affects our life, means some things cause and different diseases. So everything is interconnected. And same for the atmosphere, and same for the industries and the academia. If they're linked, then we can make our planet better. But without this, it's impossible. When there is strong linkage, then we get the better effect on the environment, as well as even economy, the growth, as well as the temperature and sustainability. We get these objectives better, but when we are strongly linked. Otherwise, it's impossible. Students thought that we write a lot of papers, but when we implement, and we need also a thought process. Even in, if we are teaching, we give them smaller tasks and then a thought process. But we don't know what is the actual thought process, how we get a problem, what are their solutions. And if we make this type of practice and then we link our research, what is the effect on the environment? And that things mean with the passage of time, we get the improvements. Thank you.
Okay, I just want to endorse and want to share one case. There are multiple solutions developed by the academia, but in practical, these solutions are not economically viable. That is the reason why industry refuse to adopt new products and those solutions. I have one case. Once we received a new product, a proposal to develop a new product that was from the EVA waste. And the claim was that EVA waste can be converted in a compound that works like a latex. So we start working on this proposal, but as a HEC person, I consult that product, that solution with the industry. You know, at the final stage, when we asked the industry, the first question was, what is the price? At that time, the proposed price was around 200 rupees per kg. And the people sitting from the industry side, they say that, okay, the latex is available in just 60 rupees per kg. Why should we adopt this solution? So that is the reason. So I want to add that when academia is working on new solutions, they must consider this cost effectiveness, the economic viability. Because most of the time they go for the innovation, they go for the new product, and they totally ignore that the solution is economically viable or not. Another thing, actually this discussion started from the what we are missing in our syllabus. So I believe that there is a specific course, a module we should teach to our students and the researchers on economics, because if something is not cost effective, that is useless. Even the money we spent in R&D, that will be wasted, and that solution will be there for in a library or in a repository, and that's it. So
thank you so much for sharing such insightful views. I'm afraid we, due to the shortage of time, we would like to conclude the session, but I would like to thank everyone who actively participated. It was a very interesting session. We would now be moving to the final speaker of the day. We have Professor Philip Longhurst from Center for Low Carbon Energy at Cranfield University. He will talk about the opportunities and challenges surrounding resource management in the pursuit of a net zero future. So can you hear us?
Yes, yeah. Good
Please
afternoon,
proceed.
everybody. Thank you.
Yes, please proceed.
Thank you very much. So I'm just going to share my screen. One moment. And as I do so, first and foremost, I'd really like to thank everybody for the opportunity to meet virtually. Our plan is to meet in person, and for all the preparation and assistance being given in arranging this trip. So it's really appreciated. Thank you. So the presentation I was going to give was a little bit about some of the resource challenges, something about the scale of change that needs to take place, and then some illustrations of work that we're doing, and we're really keen to collaborate with partners on a whole range of work related to materials, energy, net zero, towards that's land, energy and water, and materials, I should say. The first bit of the presentation is probably a little bit of a shock in terms of the challenge we actually face to achieve net zero, and then something towards the end which really should give us a bit more hope that there is work underway around the world, including at NUST, of course, and that there are great opportunities ahead. So it's not all downhill. So if we think about the challenge in terms of infrastructure development, this is a really huge task. We're currently facing some of the biggest infrastructure challenges we've ever faced around the globe. Never before have we developed infrastructure on the scale to achieve net zero as we're facing right now, because it's never been global before. We've always faced this in one region and then around another region of the world. And we have a global challenge for energy, water and materials. So what I want to look at is the infrastructure, the legacy that we have to deal with, and some options and thoughts and examples for transition. And central to this is how we manage our materials, the materials we have in place, the materials that we're going to develop and need to develop and use, and how we switch from one process to another. So what is the scale of the challenge? Well, here's our population, world population growth from 1700 to 2100 prediction. And you can see that whilst the thin line, the narrow line here, is actually reducing, so world population is slowing and is declining, and has declined roughly since the mid-90s, early 2000s. The total global population is increasing, and that's happening across Europe and around the world because people are living longer and having, in general, healthier conditions. So the question then is, what is sustainable? And how do we manage our infrastructure? What is in place right now? And how do we manage this transition? Our global Sustainable Development Goals show just how complex this is, from 17 goals. So when people talk of this is more sustainable or less sustainable, we really need to be more precise. Are we talking about sustainable, for example, in terms of food and hunger? Or are we talking about affordable and clean energy? Or about pollution or water supply? So when we use the word sustainable, we really ought to be thinking we're talking about at least 17 properties, if not more. And this concerns individuals, communities, the places we live, and our dependency on biodiversity in the land. So perhaps to think about three particular areas. Firstly, land, and then water, and then energy. So the famous American author Mark Twain said, by land, they're not making it anymore. We know we have a fixed amount of land available to us, and yet our care for land around the world is not that good. And we have extensive areas of land that are no longer accessible for the way that we've used them. Now, if we think of just Europe as a particular case, we have a huge dependency on land to actually keep our food stocks, our energy, our building materials, our seafoods, and the crops we use for consumption. In fact, our land footprint in Europe, unlike Pakistan, is very, very much larger than the land mass that we sit on in Europe. So what do I mean by that? Well, if we think of land in terms of a footprint, and we look at Europe, if I just look at where we are across Europe. So here is the UK, here is France, Germany, Italy, and southern Mediterranean, and these arrows show the total flow of materials from, in this case, Russia towards Europe. So the darker brown colours show the equivalent in thousands of hectares per year in trade. Now this is in 2010, so there has been changes, but that's 10,000 hectares, or a hectare is a 100 metres by 100 metres square of trade towards Europe, from across Africa, America, Australia, and large parts of Eastern Europe and Asia. Where it's closer to the beige colour shows how those countries are exporting less and have greater self-sufficiency. So why should we be worried? Why should we be concerned about that? Trade is a good thing. Well, the concern should be if we're significantly dependent upon land outside our own area. In that case, we really should be concerned, because that shows our vulnerability and inability to sustain those flows should those other countries need those resources. So what about water? So this shows the water imports, or what we call water footprints. Now the water footprint is the amount of water embodied within goods that we purchase from countries outside our own. And you can see the United States has a 19% import dependency, Greece 35, Malaysia 28, and so on. And it's also related very heavily to particular goods. In particular, you'll see luxury goods like chocolate, beef, olives, and sugar, and so on. So what does that look like if we look at a map? And this is a 2005 map where it shows green is net virtual water import, and the darker red colours are exports. Sorry, are dependency on exports. Green is independency of exports. So they are able to supply their own natural reserves. And you'll see the high level of dependency on water across Europe compared to Pakistan and of course India, which have far greater independency of water. So Europe and North Africa and North America has huge vulnerability to water dependency from exports. And there are some options for dealing with this. There are some options in the sense of we can choose to make changes to our infrastructure. For example, if we think about energy, so we've talked of land, water, and now we look at energy. We think of energy, we can live with reduced cars, battery cars, reduce long-haul flights, though not in every case, of course, and I'd like to be there with you now. Renewable energy, public transport, and so on. And these are ways of reducing our dependency on energy and our energy needs, energy inputs. And the Kyoto Agreement is saying, back on UN FCC, United Nations Agreement on Climate Change, is to reduce our footprint dependency on energy. So what does this look like in the difference between the UK and Pakistan? So if we look at Pakistan, the total energy use at the moment is roughly 5,000 terajoules per year. And that's for a population of about 323, gross domestic product, 323, and a population of 220 million. So whilst there are many, there's about 75% of the population has access to energy. It's closer to about 100 in the UK, but in the UK we have a much smaller, about less than a third, about 1/3 of the population, about the same GDP, but twice the energy consumption. So we are really high energy users. And this shows also the proportion of energy and how it's changed over time, from 1990 here for the UK through to 2020. And it shows the challenges we've got. For Pakistan, reducing coal and natural gas use remains a major challenge, particularly coal, which has grown and shown tendency to grow to meet the energy demands for the country. For the UK, this is the case in natural gas. We haven't made significant reductions in natural gas, and oil, we're very high users of oil, but our coal reductions have reduced. So what does this look like if we change our infrastructure? If we actually decide where we need to change, we've got to do something. Well, this is an illustration of the scale of investment needed in infrastructure when we think of the type of technologies, so here we have in the light blue is clean power. That's the investment that took place in 2015 globally. So this is information from the International Energy Authority. And you can see year on year there's been relatively little shift. However, if we're going to move to the net zero targets of 2035, set in the COP Community of Partners agreements that stem from Kyoto originally, this is the scale of investment that we now have to reach. So around 1900 billion US dollars. And this is an illustration of the types of technologies we would need to use, from clean power, electricity grid investment. You can see where that is from here. So for example, in the UK, we will need something like 5 to 10 times the electricity pylons that we've got in place at the moment. Measures of energy efficiency, so this is using energy more efficiently during the day, using less energy throughout our housing, and I'll talk a little bit about how we use energy in the UK in a moment. Other end uses, for example, heating and refrigeration and clean fuels. And in the UK, we face a particular challenge on transport. And if you think, well, is that the same for every country or every region around the world? This is India, the Middle East, so it includes the Indian regions, Middle East regions, the rest of Asia, Latin America, Africa, and Europe. And Europe, you can see, has made marginal progress compared to many of these regions. So every region around the world has this major challenge to achieve. Now, I want to say a little bit about this diagram, and I'll provide a link to this diagram to explain what it means. But this is what we call a Sankey diagram, and I can explain the key things really to look at. If we look here on the side, this shows that we have in total energy coming into the UK about 239 million tonnes of oil equivalent flows into the UK, either produced in the UK or from imports. And if we look at gas here, and don't worry about the numbers, it's the proportions that are really important. Here is the natural gas produced in the UK, and here is the imported gas, slightly more, 48.2 millions of tonnes of oil equivalent that we're using. And as that gas is used in the country, about 1/3 of it goes to converted to electricity, and about 2/3 flows along to be used for domestic purposes. And this is principally heating houses in the UK. So we have a major job in the UK to reduce our heat demand. And if we look at this gas that was producing electricity and we follow that through, a lot of that electricity, about half of it, goes again to domestic, which is for lighting and heating, cooking and lighting and heating. And so we then think about the proportions of energy flowing through the UK, we can see our major challenge is petroleum products, where we do produce some of our own, but we also, the oil we gain is not all suitable for petrol, so some of it is exported either as products for shipping, heavy oil, or as plastic compounds in oil refineries. So we can think of our total energy flow as industry, transport, domestic, and we use about half, 134, of our total energy that comes in. So it shows you 50% of our energy in the UK is lost or exported, i.e. unavailable, because we're either producing the wrong types of energy or we're losing it through inefficiencies. And this is not unusual for developed countries. So how can we address some of those challenges? Well, one of the challenges we're looking at doing is how we can convert our gas use that's in the grid to hydrogen and use that hydrogen at the end point for vehicles and heating and industry, and capture the carbon before it's emitted to atmosphere. So why would we want to do that? It's expensive and we use energy to do it. Well, the reason would be we have a large infrastructure legacy in the UK of gas pipelines and worth billions and billions of pounds. And unless we choose to switch that off overnight, we still are going to need the energy that comes from gas. So one of the options is to develop equipment at the end of the gas pipeline to convert to hydrogen, capture the CO2 in a fluidized bed reactor, and to use that CO2 for other long store or permanent storage processes whilst producing hydrogen, a pure hydrogen with no carbon emissions. And I show this process, and there's some web links to this process, because at the top here is a picture of our campus, and when the delegates come over to Cranfield, we'll show them this rig build that's happening for hydrogen to show this demonstration equipment. And there's also some time-lapse pictures on the website so you can see how this process build is taking place. So I started at the beginning thinking about land, water, energy, and the scale of the challenge we have ahead. And clearly when you think of the hyper process, one of the big issues we've got here is development of materials, sorption enhanced materials, and for hydrogen production on a separate process, the development of catalysts. So this particular project is testing catalyst, sorbents, and sorbents with CO2. And that's a major piece of work across our schools, in the engineering schools at Cranfield, and really important as a material opportunity. So let's take a step back and think, well, I've talked about energy. What about land? What about our land legacy? And how complex is that to deal with? Across the world is a very extensive problem of polluted and contaminated land. And one of the projects I was involved in about 8 years ago was to look at what are the options for low cost treatment of our contaminated land. And this work has continued in a number of different forms, but the first project was to look at the UK contaminated land and to try and think, well, where do polluting emissions go? Land, air or water? Now 4 of these pictures are actually in the UK. One of them is from Pakistan. I'll leave you to work out which one it is. But again, if they're not making land anymore, what are our options for dealing with a contaminated land and the large areas of waste which we've used to throw materials away? Those materials have value in their innate properties as a material. They have an energy value, and they also have a polluting value which is negative. What I mean by that is they take up land and they cost us the opportunity and the pollution treatment costs to remediate. And as an illustration, in the UK we have about 3,000 landfill sites, contained landfill site, not open landfill sites, around the country, and we have a risk of about 1,200 of those sites being close to the coast, where if sea levels rise, some of that waste would be eroded. So we have a major pollution threat that we have to deal with, and that's for the UK, across Europe, and around the world, Asia, Africa, around the world. So this problem of contaminated land is absolutely huge. Globally, it's roughly 400 million hectares of land which is unsuitable due to contamination. And there's a range of estimates about what this really is. Now, if we could grow biomass, or bioenergy on that land, that would equate to about 2,000 million tonnes of oil equivalent, or 2 trillion tons of oil equivalent. That would meet 10% of the world's total energy production requirements as calculated in 2012. So 10% of our energy problem could be solved should we use contaminated land to grow crops, if that were possible. So what does that look like in the UK? What does that equate to in the UK for sites? Well, in the UK we have about 400 or nearly 500 contaminated sites across our 65 local authorities. And in fact, surveying stopped some time ago for that, so it might be more than that. And of that contaminated land, about 60% is contaminated with metal or metal-bound compounds, metalloids. 36% is organics, things like pesticides and chemicals. Now, if it was possible for us to deal with some of those contaminants at low cost, we might be able to recover our land for use. So interestingly, what are the pollutants of those metal contaminants? And from a materials perspective, this is interesting because we have about just a third arsenic, about just a quarter is lead, and about a fifth, 20% just under, is nickel. Arsenic's not a particularly valuable material, but high toxicity. Lead is valuable and relatively stable apart from dissolving in water, and nickel, very high value. So what could we do to recover that land? Well, here are some unique plants which have properties that were discovered in the 1970s by an American researcher and also UK researcher, Cheney and Alan Baker, who both is still about, and we talked to Alan Baker quite a lot. And these plants have unique properties in absorbing metals. They're what's referred to as accumulators. Many plants are accumulators in absorbing contaminants, but these are hyper accumulators in that they absorb and concentrate the metals at a higher concentration than the ground around them. So you have bulrushes or typha, mangrove, euphorbia, sunflower, Helianthus anus, and Pteris vittata, a fern. So our question was, well, would it be possible to grow a crop, clean the land, use the crop as an energy source for biomass, and eventually be left with clean soil that could perhaps be returned to agriculture? So the question of doing that is, how will it work economically? How will it pay? Can we make it pay? So this project, the Contaminated Land for Wealth, or CLAW project, looked at developing methods to remediate the soil at low cost, cleaning land for use, recovering metals, and changing the economics of land recovery. So all different materials, metals, biomass, energy, and metals for different uses. So this was the, if you like, the calculating question of what profit could be made from recovering the metal, using the biomass, and getting the metal extracted from that biomass, when we know there'll be some cost to growing the metal, growing the biomass and taking up the metal. So what pays? Is it the metal value or the biomass energy, and how would we choose? So we did a piece of work using an extensive literature review, and I'll explain how this works in a second, where we looked at all of the studies for two particular crops. And here you'll see Pteris vittata, which, if you remember that fern down here, and Helianthus anus, the sunflower here. So here is Pteris vittata, and this graph shows how the yield of Pteris vittata varies depending on the soil it's grown on and the conditions for growth. So 600 kilograms per hectare up to 2,200 kilograms per hectare. And that's roughly the distribution that we came across when we looked at all of the literature review studies for this crop. So that was the minimum, the maximum yield, the average, the mean, the maximum yield, and the distribution, the standard distribution, the 5 and the 95%. This here is the arsenic uptake, and what this chart shows is that in general this is a skewed distribution, not a very wide, at the highest, the minimum distribution of take-up is just under 3 grams per kilogram. The average is 9.9, but it's a skewed distribution, and the chances of getting a high take-up is 22% is very low. 22 grams is very low. So this tells us that the amount of crop we can grow and the amount of arsenic it might take up, based on our literature review studies. And here is the same values for sunflower. So this is the kilograms per hectare, and you'll see here the value in terms of kilogram of biomass is significantly greater. The average compared to the fern is significantly greater, and the distribution is significantly greater. So things are looking better for using sunflower as a biomass crop. There's the arsenic take-up, not actually as good as the fern, but remember we've got a higher biomass. So the average arsenic take-up is lower than the fern, but we have a much higher biomass. And then we can look at the electrical efficiency and heat efficiency of burning that biomass and see what happens. So let's look at the results, and this uses a software called At Risk, which allows us on a spreadsheet to do a Monte Carlo analysis of that whole distribution and find out where profit occurs. So this is the formula, and I won't spend time on this, but really what it's saying is the value of the metal recovered plus the energy minus the cost to grow the plants and extracting the metal is our profit. So here we have the profit, the likely profit margin if we use the fern, Pteris vittata, from a Monte Carlo simulation of all of those distribution of results. And what it's showing is that there's a 57% chance of making a profit from up to around just under 150. In fact, it's 120 pounds per hectare. There's also a 41% chance of making a loss. So that's not far off 50-50. That's not very good news for an investment at a marginal profit. So 57% probability of achieving a low margin of profit. 120 pounds per hectare is very low margin. What does that look like for the sunflower? Well, for the sunflower we're significantly better off. There's a high probability, 90%, of achieving a good margin. And not only is that a high percentage, high probability, that margin is around 1,000 to 2,300 pounds per hectare. And the reason is it's the biomass that shows the profit. It's that biomass that creates the energy. So the value of the energy makes a difference. So what we're saying is we could grow sunflowers as an energy crop and use that energy crop to clean the land and do it profitably in the UK. And here's an example of a trial that is being carried out with our partners in China. They're actually using ferns because in this case they're less vulnerable to the weather, and this is a trial as opposed to a profitability test. And this shows the facility for combusting and collecting the ash from producing the field trial of ferns. And that's the bottom ash collected. And there's also calcium oxide arsenic recovery from the flue. So what we're not doing is putting arsenic from the ground into the atmosphere, which of course would be extremely dangerous. So what's the next steps in improving that particular process? Well, we need to understand better the biomass properties. We need to get a better knowledge of phytoaccumulation. For example, we came across some particular plants where they, just by selection, genetic selection, that's not genetic modification, but selecting by the knowledge of the genes, they were 30 times better in phytoaccumulating than other crops of the same type. So by selecting the right strain of crop, we can massively improve performance. And there's some work in York University and France, colleagues in France and in Greece and around the world on this area, and I'm sure there's work in Pakistan as well. We need to understand how to design and manage emissions so we can be more efficient, and we need to develop these techniques for different soils so we can recover the valuable metals. But phytoremediation isn't the only option, and we've also been looking at other options for wastes. And one of the fibre uses is, and this is from agave, which is a plant used for manufacturing tequila in Mexico. The bagasse fibres that are a waste, we've been studying and looking at how we can add PLA or polylactic acid to improve the bonding and fibre properties of those materials so that we can produce renewable fibre-bound composite materials that have good performance. So there are other uses for biomass waste rather than just energy. So I started looking at the scale of the challenge, the scale of investment, thinking about land, thinking about the water footprint and our energy footprint, looking at how we can intervene on existing infrastructure, looking at how we can deal with the legacy that we dealt with, and also thinking ahead in terms of how we can be more efficient. And really look forward to discussing these projects. I know the team in Pakistan right now, immediate colleagues from across the schools have a great interest in looking at how we can develop a range of projects and discussions and networks to look at the variety of material interests we've got to contribute towards net zero. So as I finish, I'd just like to say a particular thank you to all my Cranfield colleagues, Adnan and everybody who's been involved in organising and doing all the preparation, to the British Council, the Pakistan Embassy, UK and in Pakistan for all the help they've given us and collaboration and kind contact they've given us in organising the visit, and most importantly all of you at NUST or colleagues and friends for helping coordinate our visit, and for all of the huge support we've had in organising our trip, and look forward to meeting everybody very shortly. Thank you.
Oh, so that's it. Now, if anybody has any questions, so please ask Dr. Phil Longish.
Hi Phil, it's Sue here. Excellent presentation.
Matsec.
We could have really done with you to set the scene this morning, but we understand why you couldn't be up at some ridiculous hour.
No, I'll be happy to. But certainly, lovely to hear from you, and great to have a chance to talk to everybody. Thank you.
Phil, who will pay? This is just fantastic research, and one of the things that we've been exercised a little bit with is who will pay for some of this? Who's going to pay for the cleanup? Who are our industry clients, and who will be the funders of some of this excellent work?
Yeah, I think it's a really key question. We know that for infrastructure change we are looking at trillions of pounds, dollars, whatever currency around the world we have to use to support this development. We know these are huge costs. But we also know that there are investment opportunities where funders and investors are looking for long-term, stable and sustainable, or one of those 17 metrics, ways of continuing to develop. So, at the face of it, no single investor or nation can really foot this bill, and we will have to look at combinations of ways of achieving this. I think in the short term that's the immediate debate we face, but we're also seeing examples around the world of communities working together and communities setting targets and looking at how they can achieve some of this transition locally. So for example, at Cranfield, one of the things we're doing is making changes on our campus, investments now that are saving us money in the future. So for example, we've put in a biomass plant, a hydrogen ready boiler, a solar farm. We've had some grants to do that, and we've put some money in from the university. But this year alone has saved about £3 million in costs that would otherwise have been incurred by the energy price increase. So I think, short answer, the cost will fall to each individual. But the best thing we can do in terms of that cost and the transition is to look at how we can respond as communities and work with investors who are seeking a more stable way of investing in the longer term. Yeah.
Are there any more questions?
Hello, can you hear me?
Yes, I can. Hi.
Yes. I wanted to ask the question which is actually not related to this topic. Your university, Cranfield University, has a specialization in aeronautics. So I was reading that the speed of the commercial air flights has been decreased from 50 years, and that was as compared to that was in 1960s. It was reduced from 1500 knots per hour to 900 knots per hour. In the result that the passage from the Atlantic Ocean, which was in previously 2.5 hours, now has been increased to 3.5 hours. And the flight from the Islamabad to Heathrow, which was previously 6.5 hours, has become 9 hours almost. So what are you doing in this context that the speed of the commercial flights, which has been decreased by the international flight companies to achieve the fuel efficiency as well as in the reduction of the prices of the air tickets? So how can we increase? We should have increased the speeds of the planes. I think we should have achieved up to the 5 years flight from the Heathrow to Islamabad, even from Heathrow to New York. So why we can't achieve this yet?
Thank you. Fascinating question. I think there's 3 aspects to that. Firstly, about speed. Secondly, about fuel efficiency. And thirdly, perhaps more importantly, is about our fuel in the long term. Aerospace isn't my expertise area, although I do talk to colleagues in aerospace. One of the issues I think with speed is the combination of routing, aircraft performance and fuel efficiency itself. So we have aircraft that can travel much further distances, and they save fuel by not landing and not taking it off as frequently, but they may not travel as fast. So there's a whole set of economic considerations about speed and fuel consumption over time in the air or flight duration. There's also been impacts in terms of global cooperation for routing, which has had a difference. So there's a number of complex factors which I don't know the full detail about, which have affected the priority for speed over the trade-off with distance, comfort and fuel efficiency. And speed has not been the highest priority. For example, we've dropped off the use of Concorde, which was supersonic, so focused at speed. And part of that is because the demand wasn't there, and our communication, now is a great example. our communication has improved so significantly. So the pressure for speed is perhaps not as great. Secondly, in terms of aircraft development and fuel, the priority now is looking at how aircraft can transition from fossil fuels to other sources of energy. Cranfield Aerospace, a company that's part of Cranfield, has recently developed and is flying a small electric aircraft for very short distances, and is testing that as a part of a development. And we think it's likely that electric aircraft will be part of the solutions for very short or short haul distances, internal flights, small cross-boundary or cross-country such as European flights. Secondly, we're doing development on hydrogen as a fuel. Now, batteries have a problem in that you don't lose mass or you don't lose mass at all during the flight as you do with aviation fuel. Secondly, with hydrogen, you lose a small quantity of mass, but the containment for hydrogen is very heavy. So hydrogen aircraft have a problem in the medium term, but that may be a development in the future, particularly with materials for hydrogen storage, liquid hydrogen storage, where in future that may be a viable option. And lastly, sustainable aviation fuel, I think, is likely to be the most dominant solution in the short term. And we're already seeing some of the big operators like International Aviation Group, who own and operate British Airways, Aer Lingus, Iberia Air, which is Spanish Airways, and a number of other country operators. They're currently buying hundreds of millions of gallons or options on hundreds of millions of gallons of aviation fuel, sustainable aviation fuel, produced by crops, particularly in America. And the debt reduction program in America has been quite focused on SAF, sustainable aviation fuels, as an option. So you asked about speed, you asked about cost and time in the air, and you also asked about sort of what we're doing. I think we're seeing the aviation sector transition hugely, and we will see it change in the next 5 to 10 years. And it'll be interesting to see what is announced at COP28 in Dubai later on this year, where the aviation industry will come under increased scrutiny.
Thanks a lot, sir.
I hope that helps.
Thank you, sir. So are there any more questions? Sure.
This is Dr. Taha. Dr. Phil, really your presentation was very, very interesting. And before your presentation, we were discussing that how the presentation should be from the faculty, and this is a really ideal example I can tell these students, because being I am from mapping and GIS background and environmental modeling background, so you have shown very, very nice graphs and maps, and this should be, I mean, we could understand everyone from different background, they could understand it very easily. This is wonderful.
Thank you, it's kind of you.
Yes.
Thank you, it's kind.
And secondly, this is very interesting that although in Pakistan we have seen first time in UK that these types, although in Pakistan we have many open dumping sites, and I have also researched in contamination for soil and water, and but in Pakistan we also I also did research in health aspect. What is the impact of the health of arsenic and all these pollutants? So is there any health-related effects on the communities living in UK for these type of material and pollution? This is first thing. And the third aspect is there any practical example of this application? You have shown so many plants and different. Was there any, I mean, although there is research, but is there any application of these things in your country or other countries? And lastly, how can, for example, if we want to collaborate in these type of research work, so what could be the way? Thank you.
Yeah, thanks. And yeah, for your feedback on the presentation. A really interesting question. Yeah, in terms of next steps. So I'm aware of some very large-scale trials. I think it's in Guangzhou province in China that's underway, because they have a large or extensive legacy from industry, both the oil the energy and materials processing industry and electronics industry, so particularly with arsenic contamination. So that's an area where we know trials are underway in terms of crop growth. There are a number of areas where biomass is used, and including reed beds, and this is something that is in place in the UK. Reed beds are used as a phytoremediation method, as a late stage polishing or cleaning for water being discharged to the natural environment. And that's something that, so where particularly we've got runoff, let's say from landfill sites, where a bund can be created for settlement, sedimentation, where it can be irrigated or reduced and then treated through a range of reed beds before discharge to the environment. That can protect rivers. And we have some examples of that in the UK. So it's a low-cost treatment. It's not to recover the metal, but it's actually protecting the environment, which is the point you raised. And yeah, we can definitely put you in touch with colleagues who are doing work on phytoremediation and reed beds. There's colleagues in water working on that now. In terms of opportunities in Pakistan to collaborate, that will be great for us to look at sites where there is runoff taking place, and potentially areas where we may be able to trap that water, slow it or treat it with biomass, and or slow it and treat it with phytoremediation banks, soil banks. So that would be a really interesting area to look at, and yeah, be very keen to discuss and collaborate, look at areas of doing that. Interestingly, last point, we also talked to a group in Argentina where they have a lot of legacy landfill sites, and we're looking at, are there ways, for example, using wind power to irrigate leachate tanks, which could then be, once initially treated, then passed on for phytoremediation. So I think there'll be some interesting options to look at. Yeah, thanks for your question.
Thank you, sir. Anyone else would like to ask anything?
Hi, Phil here, Arshad here. I'm a professor here at NUST, and I have been working in phytoremediation since 2006. I met Professor Alan Becker once in Greece, so
fantastic.
So he was doing at that time field skill studies in China, so you again told about those studies. So the work is going on since long. The one question that always being asked whenever I do present actually, so it's recovery of metals from the plant material. So even if, for example, arsenic is accumulated within Tyrus patata or even in sunflower, and one question is that we go for energy crop. Okay, we may use it as an energy crop, but at the same time, if there is a possibility to recover the metals on commercial scale, maybe lead or nickel or even arsenic, and we may have some commercial value that can help to offset the economic component actually. So is there any progress specifically or techniques or methods that have been developed at your university or in your group, actually people working on specific models actually to, because from soil it's extracted, but then what's the fate of all these pollutants actually? So this is, if you can address this question please. Thank you.
Yeah, thanks. It's a really interesting question. So we've done a little bit of work, and this is something we need to spend more time on and seek funding to do. We've done some work modelling the separation of metals from the combustion plume at different temperatures and pressures, so that we can see, can we, for example, separate out different metal compounds as they're emitted in the if we gasify the biomass in the gasification plume. That looks possible, but we need, in modelling terms, but we need to do some experiments, and we haven't yet progressed to doing those experiments. That's for Cranfield. In across Europe, I'm conscious, and it's really good you met Alan Baker in Greece. He's often visiting there, and he has collaboration in Greece and in France. And his work is currently with I think there's 2 European projects underway where they're looking at economic recovery of metals. And I can, if you're not already in touch with those partners, I can put you in touch with those partners doing work in that area, and cite some of the published papers, because they're looking, as you say, at the economic benefit of recovering the metals, which is really the key driver, because one of the challenges with biomass is to grow large volume, you need water supplies, and that in its own right can be expensive in certain contexts. So you want to recover the maximum value you can from the crop, not just the biomass, but also the metal as well. Yeah. I hope that answers your question.
Thank you, sir. So if there are no more questions, I would like to thank Dr. Longest again for being with us and sharing his insights and proposing solutions for a more greener future. Thank you, sir.
My pleasure. Thanks very much.
And we also
Thanks,
have
everybody.
a souvenir for you, but we would like to invite Dr. Sue Impe to receive on your behalf. Dr. Adnan Syed, if you please come forward and give it to Dr. Sue. No, the video is not. Camera? यहाँ पे camera का option नहीं है. No visible camera found.
Brilliant. Thanks ever so much.
Thank you so
I
much,
really,
sir.
really appreciate it. Thanks for your kind hospitality to everybody.
We also have another souvenir for Dr. Solanitis. I don't know if I'm pronouncing it right. Celeste. Oh, sorry, I'm sorry. Okay, thank you so much.
Great, thank you. I'll leave the call. Thanks everybody,
Okay,
and
thank
great
you,
to meet
sir.
everyone.
Thank you for being with us.
Cheers. Bye.
Bye.
As we reach the end of the conference, I will. I'm sorry. Sorry. Okay, as I was saying, we have reached the end of the conference, and I would like to thank all of you, the esteemed guests, faculty members, fellow students for being here today and making this conference a success. I would especially like to acknowledge the amazing organizing committee for their efforts in bringing this conference together. And sorry, I was saying, and I would like to extend my gratitude to the honored guest speakers for enlightening us with such interesting and motivating insights. We take great pride in being a part of this ideology that aims to make an evident change to tackle the existing environmental concerns prevailing in the world today. I hope you all found this conversation interesting and informative. It was an immense pleasure having you all here today, and I hope to have more such sessions in the future. To conclude our conference on this positive note, I would like to invite you all for a tea session. Enjoy the tea and safe travels to those who are heading home. Until we meet again, keep the spirit of collaboration alive and continue to be agents of positive change in your respective fields. Thank you so much, everyone.